The main difficulty of this question is that they give you loads of little bits of information and you have to put them all together at the end. So let's try to do it. They give you information to calculate the MR, so we do it, it's 192, fine. They tell you that you have 7 oxygens, carbon and hydrogens, okay, fine. They tell you that 1 mole of acid needs 3 of sodium hydroxide, so that means you have a triprotic acid, so 3 carboxylic acids. Now they tell you that you have a tertiary alcohol from this bit, fine. So overall you have 7 oxygens from the formula. We know 1 of them will be the alcohol, and the other 6 will come from the 3 carboxylic acids. Alright, so now let's try to come up with a structure that has got an MR of 192, and you can only do trial and error. So the way I would do it is this. We know we have a tertiary alcohol. That's going to be our starting point. I'm going to do a skeletal formula. So that's a tertiary alcohol. And now here, we know it's a tricarboxylic acid. We could put here 1 carboxylic acid, 1 here, and 1 here. And now we check. So the molecular formula for this one is going to be where we have 1 carbon, 2, 3, 4. So we have C4. Now, how many hydrogens? You could count them, but I don't like counting them. I prefer to do this. We have 4 carbons. If we had no double bonds, then we would have 4 times 2 plus 2, which is 10 hydrogens. But for every double bond we have, we remove 2 hydrogens. Because we have 3 double bonds, we remove 6 hydrogens. So 10 minus 6 gives you 4. And then 07. You calculate the MR for this one, and you will see you don't get 192. You get for 12 times 4, which is 48, plus 4, plus 7 times 16, which equals 164. Okay, so we are how far away from 192? We are 28 units away. 28 units, that's probably 2 CH2 groups that we need. Okay, so we need to add 2 CH2 groups, so we start with the same thing, tertiary alcohol. Okay, and now we have, instead of putting the carboxylic acid here, CH2 group there, carboxylic acid. We needed 1 more CH2 group, so maybe here, and now carboxylic acid. And the other one here. So now this one has got a formula which is C, how many carbons? 1, 2, 3, 4, 5, 6. C6, and then H is going to be 6 times 2 plus 2, which is 14. Taking away 6 is 8. 07. You calculate the MR for this one, I believe is 192. Fine, so we've got quite a long way into the question. Now we need to have only 4 peaks. So let's see. This molecule is symmetrical. So let's see, maybe I've got it already. So that's carbon is unique, that's 1 peak. This carbon is unique, that's 1 peak, 2 peaks. This carbon and this carbon are symmetrical, so that's 3 peaks. This carbon and this carbon are symmetrical, so that's 4 peaks. So I've got it already. Could you have more structures? Probably yes. I think before I did it and I got a different one, but it's just a matter of trying. Let me see. Just out of curiosity, maybe it doesn't work, but that's the fun of it, isn't it? So what if I put a CH2 group here, and now I put a carboxylic acid there, and another one there, and then one here, would that work? You check it. I'm running out of recording time. I think this one, I think it wouldn't work. I think I've got the wrong number of carbons anyway. But as I said, it's a matter of trying. That's it.